Okay, so welcome back, and now we're going to move on to a reasonably basic network with one router in it. And if you remember from our earlier discussions, we use a router when we want to communicate between different networks. So the scenario that I've set up here is one based on the American Dad cartoon. On the left-hand side, we have the parents network, and on the right-hand side, we've got the kids network. Now, practically speaking, if you were ever to set up something like this, it actually would make sense, because you could, in essence, segment your kids network into a separate network, or students or library patrons or whatever the case may be, as this is how it would practically work. And you would give them certain access rules. So for them to get in and out of the internet, they would have to pass through, let's say, LAN 2 on the router in this case, and this port, or the firewall port in the router, on the router I should say, would examine all the communications coming in and out. So you could actually specify and be quite specific as to what they're allowed to access or not allowed to access, whilst on this side maybe the parents network has much freer access, for example. So what I've done here in this network, I have everything set up as you see. I have the names of the PCs changed in the background for the log, so I went right click, if you remember, and set description, and I've changed to the relevant names. I do the same for the switch and switch 2 over here as well, just so we can follow them as we go through. Now I've specified up here that the parents network is 10.10.10.x/24. Now, if you remember from the discussion, /24, so there's 4 octets, 8 plus 8 plus 8 plus 8. So in essence, that would also, or could also be written as 255.255.255.0. So how this looks, when we go into netcards, I'm going to put in the IP address. We'll put in the first one as 10.10.10. I'm going to start at, we'll start at 1, and we can come back to it. The masks here, so what we were saying earlier, so there's 8 potential ones here. 8 potential ones, 8 potential ones, 8 potential ones. In this instance, where you see 255, all the ones have been used. None here, none here, none here. But I've specified that I want you to use 24. So what we should do is put in 255 here and 255 here. Now, in practice, what this means is the last octet in the sub-network is available for use for us in this specific example, i.e. the American Dad network. What that means is there's 8 ones here, or potentially 8 ones, so it'd be 2 to the power of 8, which is 256. Minus 2, if you remember from class during term, because we don't want to use the original network address, which would be analogous to a street address. So I'm sending this mail to Ainger Street. We need to be much more specific. We don't use the last address because that's a broadcast address to everyone on the street. So in this case, in our American Dad network, we have the potential for 254 hosts using this type of sub-network mask. Okay, so once that's done, I'm going to click on Apply and click on OK. And you can see the packets of data are already shooting out. So I'm just going to pause the simulator. I don't want that to go out yet. And let's do the same to Francine. And we're going to do Francine 10.10. Oops, 10.10.10.2. And go 255.255 to hit the /24 that we were just talking about. Now on Steve, let's do the same thing. So Steve, in this case, is 11.11.11.x/28. Okay, so if we have a quick look here, so in this case we have 28 ones is what we're looking for. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. That is equivalent to /28. And that will translate back to 255, 255, 255.240. And the conversion, if you remember, if you wanted to draw your legend out, so over the first one, just write out 8 ones or 8 zeros someplace. And over the top left-hand corner, put in 128, 64, 32, 16, 8, 4, 2, and 1. all of them added together will give you 255. So in this case, if I was to add 128 plus 64 is 192, plus 32 is 224, plus 16 is 240. So I know that this is going to end up at 240. So let's just close that off. Okay, so kids network 11, 11, 11.1. It's going to be 255, 255, 255, and we're going to go 240. Now what this in essence means is we have 4 zeros to play with at the end. So 2 to the power of 4 is 16. And again, 16 minus 2 is 14. So in the American DAD family network, we only have 14 potential devices that can be on that network segment. So it would be quite a tight network segment. It would mean that we're planning the efficiency of our numbers to be quite tight, which is good. Let's do the same to Haley. So 11, 11, 11, 2. And go 255, 55, 240. Click on apply and click on OK. Now you can see everything's gone green. So green, green. The switches know they can receive communication, as does the router. Now I've done nothing with the router yet. Okay, so what would we expect to see? Should I be able to send data from Stan to Francine? And the answer is absolutely I should. Let's play the simulator. Now you will see that the little packets of data coming out here are the ARP requests. I think we've dealt with them in a fair amount of detail, so I'm not going to mention them at the moment. But I would expect once the ARP requests have been completed, you can see Francine actually just communicating back to Stan. So the next order here should be a sequence of UDPs coming out, going through the switch network. So the switch has learnt how to communicate to Francine directly. So if we were to right click and show the switching table, so you can see on LAN 1, so LAN 1 is Stan's MAC address, on LAN 2 is Francine's MAC address. No mention of router 1 yet. If you remember, I haven't actually programmed the interfaces in, so there's no IP address, so it's not communicating on the network yet. The same would work over here at this side for Steve and Haley. So if I wanted to just communicate between these guys, this would absolutely work fine the way it's done. Now, to get the actual rooted network working, we have a few other bits and pieces to do. So on net cards, now the interface here is quite important. Okay, so interface 1 all the way to the left is on the parent's network, the 10 network. Interface 2 all the way to the right is the kids network. So LAN 1, LAN 2 corresponds to interface 1 and interface 2, and you just need to be careful that you're using the right set of numbers for this. So if we start off with 10, 10, 10, and in this case I'm going to go all the way up to the very last address that we potentially use, which is 254, and we'll go through that in more detail. So the mask is 255, 255, 255, and click on apply. So this will work as, so remember, this is the default gateway. You can already see the ARP request going out, been sent out to both Francine and Stan. Say, hey, how you doing? I'm interface 1 on router, and this is my MAC address. So let's click on LAN 2, and let's give this an IP address again. This one will be 11, 11, 11 dot, let's go 254 again. And 255, 255, 255, 240. Going to click on OK, apply and OK. Now, do we expect communication to run between both of them? And the answer is no, not yet, because there's a few things that we still haven't done. So what haven't we done? Well, for a start, we haven't enabled routing on the PCs to tell the PCs that routing is possible. And on the router, every router needs a protocol to be able to route. So let's right click and programs and add. In this case we want to add a RIP, a routing information protocol, and install it. Now you can click into settings if you wish and just have a look around. There's not much to be done here. Defaults are fine. So now the router is set up with a routing protocol. So let's go to Stan and properties and enable routing. Now we need to tell the computers where the default gateway is. The default gateway, if you remember, is the address computers are, in essence, they all go to this default gateway when they can't handle the communication within their own network segment, i.e. let it up to the router to figure out what to do with it. So for example, if Stan wanted to go to the internet, well, we don't know what Facebook's address is. It's not within our network. We have no idea how to handle it. So Stan, by default, Stan's computer would know it's outside its subnet. It would just dump it to the default gateway. Let the router figure it out. So we need to tell all our devices what the respective default gateways are on each interface. So in this case it's 10, 10, 10, 254, and apply. If that address is wrong, it will not be able to find the router. Do the same for Francine. So 10, 10, 10, 254, and enable routing again, and apply and OK. Do the same over here with Steve. Properties. So this one's 11, 11, 11, 254. Enable routing, and apply. Okay, so now it's telling me we can't set this gateway. The error there, I would imagine, is at the router side, so we'll have a look at that. So cancel. Just let's look at interface 2. So 11.11.11.254. So that looks okay. So let's see what's going on. 11.11.11.254. Apply. Okay, let's come back to that in a minute. We'll try the same on Haley's computer. 11.11.11.254. Okay. So it's not liking the interface I've put on number 2 on the router for some reason. So let's have a look at this. I might have made a mistake in my calculations. So I'm just going to make so LAN 1, LAN 2. I'm going to change the mask here to 0 for the moment, just to ensure my calculations are correct. So 11.11.11.254. Apply. Change that to 0. So I'm just changing the mask to /24 every place, just to make sure I haven't made a mistake in my calculations. 0, apply, OK. And that setting has taken 11.11.11.254. So let's give the default gateway a try again. 11.11.11.254. Apply. Okay, so I must have made a mistake in the calculation. We can have a look at that at a later stage. Default gateway 11.11.11.254. Click and apply. Click on OK. And just enable routing on the router. Okay, so now we've changed everything, or we've checked everything that we need to. So let's see if we can send communication from Stan. When you're not sure communication is going to work, I would start off with UDP. It's a much lighter protocol. So click on next. Let's go from Stan to Haley. Okay, and really the crux of the issue is whether it gets through the router. If it gets through the router, pretty much everything is fine at that stage. Okay, so that's a very good start. Perfect. Okay, so let's try a TCP connection from Stan to Haley. Actually, we'll go Stan to Steve. So you can see here the TCP handshake protocol has been sent out. It's going to cross over to the router. Open to switch 2 and open to Steve. Again, if you're looking for more detail, you can always show log. Now, as your diagram gets more complex, the screen obviously size gets a little small. So just keep track now on Stan. So Stan now is sending everything. So what did it receive from Steve? You receive an acknowledgement. Perfect. So Stan is sending everything out. As a matter of interest, what Steve just received there was a RIP. So if you remember from our discussions in class, the router will constantly send out updates to let everybody know that it's still active, that it's on board, that things are pretty much working okay. So that's just the update. And you can see also that Stan received the same update. Actually, all PCs would have received the same update. Okay, and that's the basic single router based network with different network segments from family to parents, and we'll conclude that video on that. The next video we'll start looking at DHCP, and we will look at just some some looping problems with basic hub based networks. Thank you for listening.